Dalton's law states that if two or more chemically unreactive gases are placed in the same container, each gas will exert the same pressure as if it were the only gas in the container. This means that the total pressure in the container is equal to the sum of the partial pressures of each component gas. Welcome back, everyone. So this time we're going to have the formula of Dalton's law of partial pressure. So for Dalton's law of partial pressure, our equation is P total, which is represented by PT, is equal to P1 plus P2 plus P3. So as I've said a while ago, PT is equal to the total pressure. And for the P1, P2, and P3, and so on, that corresponds to the partial pressure of individual gases. Got it? Alright, so this time let us have an application of the formula of Dalton's law of partial pressure. So for example, we have pressure 1, that is the pressure of oxygen, which is equal to 250 torr, and it is added to the pressure of carbon dioxide, which is equal to 1,200 torr. So applying the formula of Dalton's law of partial pressure, how many individual pressures do we have? We have pressure for oxygen and pressure for carbon dioxide. So we have two pressures, P1 and P2. P1 will be the pressure of oxygen, and then P2 will be the pressure of carbon dioxide. So if you're going to solve this, all you have to do is just get the PT by adding the individual pressure. So first we have 250 for oxygen, and then we have 1,200 torr for carbon dioxide. So in order to get the P total or the total pressure, just simply add. So 250 plus 1,200 will give you 1,450 torr. And that is the total pressure of these two gases. Pressure is independent of the identity of the gases, but related to the abundance of the individual gas. So for that, let us have sample problem. A cylinder contains a mixture of three gases, nitrogen, carbon dioxide, and helium. The pressure exerted by nitrogen is 420 millimeters of mercury, and that exerted by carbon dioxide is 80 millimeters of mercury. If the total pressure exerted by the three gases is 852 millimeters of mercury, calculate the pressure exerted by helium. Alright, so for the solution, we're going to have first the general equation of Dalton's law of partial pressure, which is PT equals to P1 plus P2 plus P3. Alright, so in the given problem, we have the total pressure, which is 852. And then we have P1 for nitrogen, that is 420. And then P2 for carbon dioxide, which is 80 millimeters of mercury. But we don't have the value of pressure exerted by helium. So in that case, we will have a different approach in order to solve this problem. So for our solution, we will write here, pressure exerted by helium is equal to PT, which is 852 millimeters of mercury. Remember, PT is the total pressure. So in order to get the total pressure exerted by helium, we're going to subtract the sum of the pressure of nitrogen and carbon dioxide from the total pressure in order to get the pressure exerted by helium. So in that case, we will add first 420 plus 80 millimeters of mercury, which are the pressure exerted by nitrogen and carbon dioxide, and you will get 500 millimeters of mercury. So since we have already the total of the pressure of nitrogen and oxygen, we will subtract this from the total pressure, which is 852 millimeters of mercury, so we can get the pressure exerted by helium, which is 352 millimeters of mercury, because 852 minus 500 will give you 352 millimeters of mercury, and that is the pressure exerted by helium.